a graduate student at Osaka Institute of Technology. Thank you for gathering here today. I will now begin my presentation. The title is Study of Voice Generation Methods Suitable for Characters Based on Human Cognitive Characteristics. Have you ever had this experience? I have one question for you all. What do you imagine the voice of the character on this list to be like? Would you imagine? When a character has voice in this way, there is sometimes a sense of discomfort. Therefore, I wondered if these problems could be solved using information technology. So, what can be done to solve the problem? Uh, I shall use the process of seeing the character's face and imagining their voice in this study. First, research has shown that this is some relationship between a real person's face and the voice they have. It has also been shown that imaging a voice from a face can also be said of a character's facial image. I will then introduce my related search. Related search examines whether it is possible to estimate voice from character image features. In this study, it was states the people imagine a voice from a character's face image by looking at the shape of the eyes. The VGG16 was then used to classify character face images and similarity classification by each part of the face. Similarity classification with character face images was then performed using experimental participants. A wise explanation of similarity classification is that if you imagine a voice from the face of character one, the voice of character one is classified as a character with eyes of character A, and so on. A comparison of the results when estimating with VGG16 and humans resulted in a recognition discrepancy. Therefore, in this study, a countermeasure is taken by mapping voice to character when estimating. This is followed by the purpose of this research. In this research, the idea is to match the character's face with the imaged voice, and so solve the discomfort that occurs when the voice is added in animation and the like. The aim is therefore to calculate the degree of agreement between the face and the voice as passive by humans, and to generate a voice for the character based on the results without any sense of discomfort. And I would like to draw your attention to this image. This is followed by a voice generation flow that matches the character. First, the image and voice features are analyzed. And then the ratio of the voice training data is determined, followed by voice training and voice generation using tactons and wave growth. Finally, an objective evaluation of the generated voice is performed. The key here is to find an allocation of voice data that matches the character. We can then determine the distribution of the voice training data based on the results and synthesize the voice data according to the distribution. Next, we consider what exactly we are going to do. In order to relate the image and sound, we employ the pairwise comparison methods. A right illustration will be given on the method. In this method, the user is asked to enter the degree of agreement between image and sound several times. 4 points when image and sound A are presented. 1 point when image and sound B are presented. 2 points when image and sound C are presented. And so on, and so on. As shown in the diagram, a number of people are asked to perform this grading. The percentage of voice training data is then calculated based on the data obtained to establish the degree of agreement between the character and the voice. This was followed by a trained data acquisition experiment. I prepared image of 4 men for this experiment. I also made one of them appear both feminine and masculine. I also prepared 4 male voices and 4 female voices. In addition, we select as many character acts voices as possible for the prepared voices. The reason for this is that the aim of this research is to generate speech that is less uncomfortable for the character. So we thought that it would be easier to achieve this aim if the source speech for the training was also formed by a character. In addition, the images and sounds were collected only from those that could be used for research purpose. Trained data acquisition experiments were conducted. A trend study was conducted using the one pair comparison methods with 8 image types and 24 voice types. The experiment was also conducted on male aged 19 to 23 years.
スマートフォンからフィーチャーフォンまでマルチデバイスに対応。
現在、ニュージャージー州ムーアスタウンに住んでいる。
現在、ニュージャージー州ムーアスタウンに住んでいる。
So, in the experiment, the image and sound are placed and the participants are asking to choose one if they feel no match at all, 2 if they feel no match, 3 if they feel neither, 4 if they feel a match, and 5 if they feel a match very much. Percentages were established from the evaluation values obtained. The figure was calculated as a percentage by comparing the overall score of the ratings obtained with a score of 1 for the least congruent and 5 for the most coherent. So sorry. Speech learning will now be performed on the data obtained. Percentages were established from the evaluation values obtained. The section provides explanation of voice learning. As shown in the diagram, voice data is round using calculated ratios such as 7% for voice A, 7% for voice B, 20% for voice C, for character number 0. For example, when running the voice of character 0, 21 voice data of voice B, and 60 voice data of voice C, and etc. are prepared by maintaining the ratios. The prepared speech is then used for speech learning based on the calculated ratios. In the study, speech learning is performed to taxons and speech generation is performed in WaveGrow. The details and parameters for speech training are 270 texts for training data, 1,000 evokes, 30 texts for test data, and a batch size of text 16. Cross validation is performed in this study. Based on this information, the percent study learning and generated speech sounds. Speech generation was performed based on the obtained trained data. As an example, we will play the synthesized voice of each character. Could you listen to those voices? Next. He said, my name is Kimura. How was it? Did the move of characters' face match their voice? I confirmed that the sound I had generated earlier matches the image. In this study, I also conducted an experiment to confirm the match with image. Next, we will perform a confirmation experiment with the image. In this experiment, we tested whether the generated voice matches the character's image. In this experiment, we present the generated synthesized voice as the character image is just serves as the basis for the voice at this same time. And asked participants to rate the image and voice on a five points scale, ranging from very inconsistent to very interesting.
歌手の名前は木村です。私の名前は木村です。
The survey was conducted among 27 men and 7 women between the ages of 19 and 33. Shown the results of the the results of the confirmation experiment with the image then shown. The results show that the sum of character 5 matches the image the best, and character 0 matches the image the least. Character 0 is the least consistent with the image. I also found a one sample proportion test on each results. The results shows a significant difference in the results for character 5. I also found a semantic analysis on the free text statements obtained during the experiment. The common features that the participants in the experiments found to be important were the mechanics of the voice, the difference between high to low voices, and discomfort were seen to be important. We will now look at the results, focusing on the results for character 0 and character 5. A confirmation experiment with the image of character 0 is shown. As a result, the majority of results were that they did not match, and there were very few opinions that agreed. It is thought that this is because the character's appearance is strong. So distinctive voice data was required. Moreover, there is no significant difference in this results. Next, the results of semantic analysis using character 0 are shown. Looking at the results in terms of intonation, we received opinions such as it has a strong mechanical voice and the accent is strong. In addition, regarding the difference in pitch on the voice, opinions such as I thought the voice sounded deeper, and I feel like the tone of the voice is higher than it looks. We are received. Regarding the atmosphere of the voice, there were also comments such as the image of the voice of the man in this video and the voice. I heard the difference, and I don't feel they match. From this, it is assumed that the poor results were due to intonation being strong. The pitch difference in the running data voice not being enough, and the atmosphere of the voice not matching in the first place. A confirmation experiment with character 5 image is shown. As a result, there were many opinions that said they were in agreement, and if they include other opinions that said they were very much in agreement, it can be seen that just 25 out of 34 people have good evaluations. It is thought that this is because the character mood, pitch difference, and intonation matches the voices. Also, there is a significant difference in these results. Next, the results, the semantic analysis using character 5 are shown. Looking at the results, one commenter says that its tone's intonation, there was a pitch bit of mechanical noise, but the pitch was about as expected. Regarding the atmosphere of the voice, we received opinions such as, I was imagining a Moe voice, so I thought it was close to that, and it almost matched the impression of the face. Also, there was almost no mention of the difference in pitch between voices. The reason for this is thought to be that the experiment participants hardly felt any discomfort. Based on this, if there is no significant discomfort in the intonation, pitch difference, or atmosphere of the voice, it turned out that it was easy to get good results. The next section presented discussion on semantic analysis. In the case of good results, it was found that the generated voice produced a voice haze close to the atmosphere of the image, with no sense of discomfort and good intonation. In the case of poor results, the generated voice was found to have a strong mechanical feel, as it requires a distinctive voice data from the image, and it did not match the mood of the face with the voice. Therefore, it is considered necessary to increase the number of types of high and low differences in the training voice. Increase the number of face and voice matching experiments using the one pair comparison method, and adjust the intonation if a less uncomfortable voice is to be produced. The results of the experiments showed that when the speech language of the specific training source and the speech language of the generated speech are close, as shown in the diagram above. The speech language of the training source is strongly inherited. The results of the experiment showed that when the language of speech of the particular training source and the speech language of the generated speech are close, the speech of training source is strongly taken over, as shown in the diagram above. The results of the experiment bear as follows. The language of the source speech should be matched to the language of the generated speech. The following section describes future prospects. Future prospects includes new learning of intonation aspects, augmentation of speech training data, additional experiments for acquiring trend data. enabling training data calculation to be calculated automatically by machine learning, and matching the speech contents of training data. I believe that this could be used for future developments, such as casting voice actors, voice actors for animated films and voice books. Next, I will present my conclusions. As a result, I have succeeded in generating a synthetic voice with a minimum of comfort using a pairwise comparison methods of data adjustment. Therefore, it can be said that I have achieved my goal of generating speech with less discomfort. Therefore, in the future, I would like to increase the amount of speech data based on the experience of less uncomfortable speech. Conduct further pairwise comparison experience and further investigates machine speech. Then a summary. Thank you for listening to the presentation.